Dear students, welcome back to the channel. Today we are going to solve some real numericals that were asked in previous annual exams. These questions are super important because examiners or question paper setters love in repeating the same kind or same type of questions. So if you practice these, you will definitely feel more confident in your exams. So let's crack one by one. And don't forget, stay with me till the end for a quick tip to score full marks in numericals. Let's see the first one. In this problem, we need to find out electric field at a distance of 20 centimeter from the center of this spherical shell, as well as at 5 centimeter from the center of the spherical shell. Now, the given data is radius of the spherical shell is 10 centimeter and surface charge density is 16 microcoulomb per meter square. So, we know that an expression for electric field outside the spherical shell is E equals to 1 by 4 pi epsilon naught Q by R square. But here we don't have Q. So, we can extract this Q from the given data, that is sigma. So, here sigma equals to what? Sigma equals to Q upon area of cross section. The area of the spherical shell is 4 pi R square. So, if I rearrange, I will get Q equals to sigma 4 pi R square. Now, substitute this Q here. Then you see 1 by 4 pi epsilon naught Q equals to sigma 4 pi R square divided by small r square. Here 4 pi get cancels. We will left with sigma capital R square divided by epsilon naught R square. And substituting the values here, sigma equals to how much here? Sigma equals to 16 times 10 to the power of minus 6 because micro here. So, R square, capital R square 10 centimeter, and here 10 into 10 raised to minus 2 whole square divided by epsilon naught 8.854 into 10 raised to minus 12 R square. Here this is 20 into 10 raised to minus 2 whole square. On simplifying this, we get, you see, 16 into 10 raised to minus 6, here 10 square 100, 10 to the power of minus 2, 10 to the power of minus 2, 10 to the power of minus 4 divided by 8.854 times 10 to the power of minus 12, and here 20 square is 400 into 10 to the power of minus 4, and here this 10 to the power of 4, 10 to the power of 4 and 100 and 1 ja 100 4 ja, and here 4 1 ja 4 4 ja. So, here we left with 4 times 10 to the power of minus 6 divided by 8.854 times 10 raised to minus 12. So, on simplifying we get 0.451 into 10 raised to plus 6. So, this can be written as 4.51 times 10 to the power of 5 Newton per coulomb. This is the electric field at a distance of 20 centimeter from the center of the spherical shell. Now, the another question is the electric field at a distance of 5 centimeter from the spherical shell. Directly we can take electric field at a distance of 5 centimeter from the center of the spherical shell is 0, because according to Gauss's law, electric flux through a closed surface depends only on the charge enclosed by it. But if you imagine the spherical Gaussian surface of radius 5 centimeter inside the given spherical shell, then the total charge enclosed by this Gaussian spherical shell of radius r is 0. There is no charge at all. If there is no charge, then there is no flux. If there is no flux, then electric field equals to 0. So, let us go to the next problem. In this problem, we need to find out resultant electric field at this point at C. Here we have two charges which are placed at the A and B of equilateral triangle of side 0.2 meter. Now, electric field due to this charge 2 microcoulomb will be acting in this direction because it is a positive charge, no? So, this positive charge, and here this is also positive charge, so that electric field will be acting in this direction. And let me consider this one is EA and this is EB. This is electric field due to the charge 2 microcoulomb and EB is electric field due to the charge 3 microcoulomb, and these two are vectors which are acting at an angle of 60 degree because it is an equilateral triangle, so that. Now, we can find out EA. We know that electric field due to an isolated charge is 1 by 4 pi epsilon naught Q by r square. And here EA is equals to, we can have EA is equals to 1 by 4 pi epsilon naught is 9 times 10 raised to 9, and Q, here how much Q we have here? We are going to find out EA. EA is electric field due to the charge 2 microcoulomb which is placed at point A. So now Q is equals to 2 microcoulomb divided by r square, the distance is 0.2 whole square. Now simplifying, we get 9 times 10 raised to 9 into 2 times 10 raised to minus 6 divided by 0.04. This can be written as 9 times 10 raised to 9 times 2 into 10 raised to minus 6 divided by 4 times 10 raised to minus 2. 2 1 ja, 2 2 ja, 2 1 ja, 2 4.5 into 10 to the power of 9. So 10 to the power of 5 Newton per coulomb, which is acting along AC. This is EA. So EA is equals to how much we got? EA equals to 4.5 times 10 raised to 5 Newton per coulomb. In the same manner, we can find out EB, and EB is equals to the electric field due to the charge 3 microcoulomb which is placed at B, that is equals to, so here 9 1 by 4 pi epsilon naught value is 9 times 10 raised to 9, and Q value is 3 times 10 raised to minus 6 divided by 0.2 whole square. So just now we have seen 9 into 10 raised to 9, 3 into 10 raised to minus 6, 0.2 whole square can be written as 4 into 10 raised to minus 2. So on simplifying, we get 6.75 into 10 raised to 5 Newton per coulomb. This is EB, and these two electric fields are acting at an angle of 60 degree. So now we have to use superposition principle. This is a vector sum, because electric field is a vector, so we have to use vector sum. That is nothing but the resultant electric field is equals to square root of, vector sum is square root of EA square plus EB square plus 2 EAEB cos theta. Here theta equals to how much? Theta equals to 60 degree. Cos 60 is 1 by 2. And substituting all the values, so square root of EA, here EA equals to how much? 4.5 into 10 raised to 5 whole square plus EB equals to 6.75 time raised to 10 raised to 5 whole square plus 2 times 4.5 time raised to 5 into 6.75 times 10 raised to 5 cos 60. So on simplifying this we get 9.81 into 10 to the power of 5 Newton per coulomb. This is the magnitude of resultant electric field which is acting at the point C. Let us go to the next problem. In this problem, we need to find out electric field at the midpoint of these two charges, as well as the force experienced by the 20 millicoulomb which is placed at the center of these two charges. So first let us find out the total electric field due to these two charges at the O. Here this is positive charge, so that the electric field will be acting in the outward direction at this point O. So let me consider that one is EA. EA is the electric field produced by 15 microcoulomb, whereas the EB, let me consider EB is the electric field produced by minus 10 microcoulomb charge. So this negative charge, so that it is acting in the inward, and this is positive charge, this is acting in the outward. So that net electric field is equals to EA plus EB. So we know that electric field due to isolated point charge is 1 by 4 pi epsilon naught Q by R square. And here E equals to, EA is nothing but the electric field produced by this charge, so that is QA by AO square plus 1 by 4 pi epsilon naught QB by BO square. So here AO and BO both are equal, because O is the midpoint of these two charges. So let me take them outside, that is 1 by 4 pi epsilon naught as well as AO square can be taken outside, and here QA plus QB. And substituting the values, 1 by 4 pi epsilon naught value is 9 times 10 raised to 9, and AO square, AO means here total is 20 and AO is 10 centimeter, 10 times 10 to the power minus, centi means 10 to the power minus 2 whole square, and QA is 15 microcoulomb plus 10 microcoulomb, QB is 10 microcoulomb. On simplifying, we get 9 into 10 raised to 9, and 10 into 10 to the power minus 2 whole square is, we can get 10 to the power minus 2 only, and here 25 into 10 raised to minus 6. So on simplifying, we get 0.25 into 10 raised to 7 Newton per coulomb. This is the electric field at the midpoint of these two charges. Now let me come to the second part of the question, that is force experienced by the 20 millicoulomb of charge. We know that the force experienced by the charge equals to electric field times the charge, and E is equals to, here just now we got E is equals to 2.25 into 10 raised to 7, and here charge placed at the point O is 20 into 10 raised to minus 20 millicoulomb, and 2.25 into 20 is 45, 10 raised to 7 and minus 3, here 10 to the power 4. Let me express to the one decimal place, that is 4.5 times 10 raised to 5 Newton per Newton is the answer. F is equals to 4.5 into 10 raised to 5 Newton. This much force is experienced by the charge which is placed at O. Okay. Let's go to the next problem. So in this problem, we need to find out distance between the two spheres. The one sphere having the charge 0.4 microcoulomb, I have taken that one as Q1, and another small sphere having the charge 0.8 minus 0.8 microcoulomb, that one I have taken as Q2, and force between them is 0.2 Newton. So and also we need to find out the nature of the force as well as the force on the second sphere due to the first sphere. So let me find out first the distance. So from Coulomb's law we can take F is equals to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. Let me take this R as D square. Make D as a subject formula now. On rearranging, we can take D square is equals to 1 by 4 pi epsilon naught Q1 Q2 divided by F. And substituting the values, we get 9 times 10 raised to 9, and Q1 is 0.4 into 10 raised to minus 6, and 0.8 into 10 raised to minus 6 divided by force. How much force we have here? 0.2. And here we will get 9 into 10 to the power 9, and here we can take this one as 4 into 10 raised to minus 7 into, this is equals to 8 into, let me take this one, 8 into 10 raised to minus 7 divided by 0.2. So on simplifying this, we get 144. So here D is equal, so that D is equals to square root of 144. So this is equals to 12 centimeter. So distance between these two spheres is 12 centimeter. Now we need to find out nature of the forces. Here these two charges are opposite in nature, so that this force is attractive. Okay, the attractive force, because Q1 and Q2 are opposite in nature. Opposite charges always attract each other. Next, they are asking you to find out the force on the second sphere. We know that the Coulomb's law obeys Newton's third law. So according to Newton's third law, the action and reaction both are equal but opposite in direction. So that the force experienced by the first charge is how much? 0.2 Newton. So that force experienced by the second charge is also same, that is equals to 0.2 Newton. Force experienced by the second charge due to the first charge is 0.2 Newton, because according to Newton's third law. Let me go to the next question. So in this problem, you need to find out distance between the two spheres, as well as we need to find out the force between the same two spheres when they brought in contact and placed them in their original position. Okay, so first let me find out the distance between these two spheres. So we know that from the Coulomb's law, F is equals to 1 by 4 pi epsilon naught q1 q2 by r square. So here make r as a subject formula because r is the distance between the two spheres. So here we can take 1 by 4 pi epsilon naught. Let me take r square equals to 1 by 4 pi epsilon naught q1 q2 divided by f. And here 1 by 4 pi epsilon naught value is 9 times 10 raised to 9 and q1 value is 0.6 into 10 raised to minus 6 and q2 is 1.2 into 10 raised to minus 6 divided by force is how much here? 45 into 10 raised to minus 3. So on simplifying this we get r square is equals to, on simplifying this we get r square is equals to 0, we get 0.144 and r is equals to square root of 0.144, square root of 0.144. This is equals to 0.379 and approximately equals to 0.38 meter. This is the distance between the two spheres. Now in the second part of the question we need to find out the force between the same spheres when they brought in contact and placed them in the same position, that is nothing but at a distance of 0.38 meter. Here the total charge before contact is q equals to q1 plus q2. Here q1 equals to 0.6 and q2 is minus 1.2 microcoulomb and this is equals to 0.6 minus 0.6 minus 0.6 into 10 raised to minus 6 microcoulomb. And here these two spheres are identical in nature, so that the charges will be equally distributed. So q1 dash is equals to q2 dash. Let me take q1 dash is equals to q2 dash is equals to minus 0.6 into 10 raised to minus 6 divided by 2 because they are identical, so that the charges equally shared between these two spheres. So this will become minus 0.3 microcoulomb, 3 into 10 raised to minus 6 coulomb. Now let us find out the force between these two spheres which are having the charges 0.3 into 10 raised to minus 6. F is equals to, we know that 1 by 4 pi epsilon naught value is 9 into 10 raised to 9 and q1 is equals, let me take q1 is 0.3 into 10 raised to minus 6 and qt is also same, that is 0.3 into 10 raised to minus 6 divided by the r square. Here you know that r square is equals to how much here? 0.144. Let me take directly 0.144. So F is equals to, on simplifying we get 5.625 into 10 raised to minus 3 Newton. This is the force between the two charges when they brought in contact and placed them in their original position. Okay. Let's go to the next problem. So in this problem you need to find out force between these two charges as well as the force between the same two charges when the distance between them is doubled. Okay. First let me find out the first case, that is force between them. So we know that from Coulomb's law we can take 1 by 4 pi epsilon naught q1 q2 by r square. Here on substituting the values, 1 by 4 pi epsilon naught value is 9 times 10 raised to 9, q1 is 2 times 10 raised to minus 7, q2 is 3 into 10 raised to minus 7 divided by r square. R is 3 centimeter square, 3 times 10 raised to minus, centi means 10 to the power of minus 2 whole square. Now on simplifying we get 9 into 10 raised to 9, 2 3 is 6 into 10 raised to minus 14 divided by, so 3 3 is 9 times 10 raised to minus 4. So this and this get cancelled, we get 9 14 and here, so 0.6 Newton. This is the force exists between these two charges. Now if r is equals to, let me take r dash 2r, if r is doubled, that is 6 centimeter to r, then what happens, you see 2 into 3 centimeter, this is equals to 6 centimeter. If it doubles, then what happens for the force? So by using the same formula, F is equals to 1 by 4 pi epsilon naught q1 q2 divided by r square. So 1 by 4 pi epsilon naught value is 9 times 10 raised to 9 and q1 is same, that is 2 into 10 raised to minus 7 and q2 is 3 times 10 raised to minus 7 divided by r square. Here r square 6 centimeter square, 6 into 10 raised to minus 2 whole square, and this is equals to 9 times 10 raised to 9, 6 into 10 to the power of minus 14 divided by 36 into 10 raised to minus 4, and here 6 1 ja 6 6 ja 6 1 ja 6 0 point, so here we will get 6 1 ja 1 point 10 raised to minus 1, this equals to 0.15 Newton. So this is the force is equals to 0.15. Let me take this one as F dash. F dash is equals to 0.15 Newton. Whenever we double the distance, then it becomes like this. Let's move to the next question. In this problem, you need to find out electric field at the midpoint of AB, that is O. Okay, here due to the 3 microcoulomb charge as well as minus 3 microcoulomb charge, there will be electric field, 2 electric fields. So one electric field is acting in this direction. Let me consider that one is E1 and this one is E2. And E1 is due to the charge which is placed at A, and E2 is the electric field due to the charge placed at B. And E1 is acting outward because it is positive charge, and E2 is acting inward because it is negative charge. Now these two are acting in the same direction, so that net electric field at O is equals to E1 plus E2. So we know that electric field due to isolated point positive charge is 1 by 4 pi epsilon naught Q divided by R square. So if I substitute here, so that is E1 is due to the charge Q1, that is 3 microcoulomb. So we can take 1 by 4 pi epsilon naught Q1 by AO square plus 1 by 4 pi epsilon naught Q2 by, or let me take this is QA and this is QB and BO square, because AO and BO both are equal because O is the midpoint. So that I can take them outside. So 1 by 4 pi epsilon naught is common. Let me take that one outside, as well as AO and BO both are equal. So let me take AO outside, and here QA plus QB. I am substituting the values. 1 by 4 pi epsilon naught is 9 times 10 raised to 9, and AO square, that is 10 centimeter, 10 into 10 raised to minus 2 whole square, and QA is 3 into 10 raised to minus 6 plus 3 into 10 raised to minus 6, and this is equals to 9 into 10 raised to 9 divided by 100 into 10 raised to minus 4, and here this is equals to 6 into 10 raised to minus 6. So on simplifying we get, so 54 into 10 to the power of 5 Newton per coulomb, or else we can take 5.4 into 10 raised to 6 Newton per coulomb. This is the electric field at the midpoint of the two charges. Okay. Now we need to find out force experienced by the 1.5 nanocoulomb charge which is placed at O. So we know that force experienced by the charge is equals to EQ. Here electric field just now we found 5.4 into 10 to the power of 6, and here the charge, the test charge which is placed at the midpoint is 1.5 nanocoulomb 10 to the power of minus 9, and this is equals to 8.1 into 10 to the power of minus 3 Newton. Okay. Let's move to the next question. In this problem, you need to find out dipole moment as well as the electric field on the axial line as well as on the equatorial line at a distance of 1 meter from the center of the dipole. Okay. Let me find the first dipole moment. We know that dipole moment is nothing but the product of magnitude of any one of the charge, product of magnitude of either of the charge and distance between the two charges. So here the magnitude of any one of the charges is 10 microcoulomb, 10 into 10 raised to minus 6, and 2a, the distance in these two is 5 millimeter, and this can be written as 50 into 10 raised to minus 9 coulometer. This is the dipole moment, or else we can take P equals to 5 into 10 raised to minus 8 coulometer. This is the dipole moment. Now we need to find out the electric field on the axial line as well as on the equatorial line at a distance of 1 meter from the center of the dipole. So you know that 1 meter at a distance of 1 meter on the axial line, at a distance of 1 meter on the equatorial line. So here the distance of point of concentration is very large than the distance between these two charges. That is 1 meter is very larger than 5 millimeter. So we can take this A is very less than R, so that we can consider this is a short dipole. So for a short dipole, electric field on the axial line, for a short dipole we can take 1 by 4 pi epsilon 2p divided by r cube, because the distance between these two charges is very small as compared to the point of concentration. They are asking you to find out the electric field on the axial line as well as on the equatorial line at a distance of 1 meter. This 1 meter is very larger than the distance between these two charges, so that it is a short dipole. For short dipole, electric field on the axial line is 1 by 4 pi epsilon 2p divided by r cube. Now on substituting the values, E axial is equals to 9 into 10 raised to 9, 2p, 2 into p is how much here, 5 into 10 raised to minus 8 divided by r cube. R means 1 cube. This is at a distance of 1 meter. So we can take like this. E axial is equals to 900 Newton per coulomb. On the axial line at a distance of 1 meter from the center of the dipole is 900 Newton per coulomb. In the same manner, on the equatorial line, 1 by 4 pi epsilon q p by r cube. And here 1 by 4 pi epsilon value is 9 times 10 raised to 9, and p is 5 into 10 raised to minus 8 divided by r cube. R cube means 1 cube. This is equals to 450 Newton per coulomb. This is the electric field on the equatorial line at a distance of 1 meter from the center of the dipole. Okay. Let's go to the next problem. In this problem, you need to find out the resultant electric field at the fourth corner. Let me find out the resultant electric field at the fourth corner due to these three charges. Okay. Now, let me consider due to this charge, the electric field is acting in this direction. Let me consider that one as E1. And due to this charge, it is acting in this direction. Let me consider this one as E2. And let me consider this one is E3. Now, to find out T3, we need the distance. That distance in the square, you know that the diagonal distance is equals to square root of side. So that we can take 2 root 2. This distance will be equals to 2 root 2, because this is square of distance, square of each side is 2 centimeters. So that we can take 2 root 2 is the distance of the diagonal. Now, E1 can be written as, we know that E is equals to 1 by 4 pi epsilon naught q by r square. So now by using this one we can find out E1, E2 and E3. So E1 is equals to, here E1 is equals to, here E1 is equals to E2, because E1 is at E1 and E2 are at the same distance. Here this point of consideration is at the same distance from these two charges. Charges also same, as well as distance is also same. So that E1 is equals to E2. This is equals to how much? 1 by 4 pi epsilon naught value is 9 times 10 raised to 9 into the charge is 4 nanocoulomb 10 to the power of minus 9 divided by r square, the distance square, that is 2 centimeter whole square. This is equals to 9 into 10 raised to 9 into 4 times 10 to the power of 9 divided by 2 to the 4 times 10 raised to minus 4. And this get cancels, and 10 to the power of minus 9, 10 to the power of minus plus 9 get cancels. We get 9 into 10 to the power of 4 Newton per coulomb. This is what E1 and E2. These two equal electric fields are acting at an angle of 90 degree. Whenever the two vectors are acting at an angle of 90 degree, then the resultant of these two, E1 and E2, will be acting in this direction. That is Let me consider that one as E4. So before going to find out E4, let me take E3. So E3 is equals to how much here? E3 is equals to 1 by 4 pi epsilon, that is 9 times 10 raised to 9, and Q here 4 into 10 raised to minus 9 divided by R square, 2 root 2 centimeter, 2 root 2 into 10 raised to minus 2 whole square. So you will come up with 9 into 10 raised to 9 into 4 into 10 raised to minus 9 divided by 4 2 into 10 raised to minus 4. This is equals to, on simplifying it, E3 is equals to 4.5 into 10 raised to 4 Newton per coulomb. This is E3. Now you can see this E3 and E4. E4 is the resultant of E1 and E2. Whenever the two equal vectors are acting at an angle of 90 degree, then the resultant of those two is equals to that E resultant. Whenever the two vectors are acting at an angle of 90 degree, then resultant is equals to E1 root 2 or root 2 E1. So in the same manner, you can take E4 is equals to, here E4 can be written as E1 or square root of E1. Square root of E1, because E1 and E2 are acting at an angle of 90 degree, so that E4 is equals to root 2 E1, and these two E4 and E3, these are acting in the same direction, so that the total electric field at the point or at the fourth corner is E3 and E4, E3 plus E4. You know that E3 is equals to how much here? E3 is equals to, here let me take directly E3 as let me write once again, E3 plus E4. E4 is equals to root 2 times E1. Now substituting the values, E3 is equals to 4.5 times 10 raised to 4 plus root 2 value. Here root 2 value is 1.41 and E1 is equals to how much here? 9 times 10 to the power of 4. So we will get total electric field at the fourth corner is equals to 17.19 into 10 to the power of minus 4 Newton per coulomb. Or else we can take 1.72 into 10 to the power of minus 5, sorry, plus, here plus we have to take plus 5 Newton per coulomb. This answer. Okay. Now try to solve the practice question on the screen and post your answer in the comment section. Okay. Let's see in the next video. Thank you.